day to you, students. Welcome to the online class once again. Last week we were able to see some problems relating to equation of the line, and today we shall be moving on to the gradient of a line. The gradient of a line. So we can define the gradient of a line as the inclination of a line to the horizontal. It can also be defined as the angle which a line makes with the horizontal, or the vertical distance traveled per horizontal distance. This is also called the slope of the line. So whenever you are given, you can be asked to find the gradient of a line. You can be asked to find the angle which a line makes with the horizontal or the vertical distance. You can be asked to find the slope. All you are asked to do is the same thing, and which is what? Gradient. So we have this diagram. We have this diagram OX, OY. That's the Cartesian, what we did last class. And this diagram is labeled, this is line AB. And we have this angle theta. This angle is equal to this angle. Then at this point, this is 90 degrees. This one will also be 90. So we said let M be the gradient of the line AB. If M is equal to the gradient of the line, then we have BC. This is Y2 minus Y1, which we did last week in the last class. Y2 minus, that's BC divided by AC, as BC is Y2 minus Y1 divided by AC, X2 minus X1. And that is equal to what? The tangent. Tangent is opposite over adjacent. Tangent is opposite over adjacent. So tan theta is equal to that. Then we can now move on to work further by saying that theta is the angle of the line AB. This theta is the angle of this line. Then theta is called the angle of the slope. This theta is the angle of the slope of the line AB. Now that is for a single line. Now a situation whereby we have two lines. We want to find the angle between the two lines. How do we do that? So if we have this is OX, OY. O is the origin. So we have this theta 1 and theta 2. Then the angle here is theta, opposite, vertically opposite angle. They are equal, so that's why we have this to be. Then, if the gradient of PQ and RS are M1 and M2, where M is the gradient, don't forget. So what we have here, we said let M be the gradient. Now we have two lines now. The first line, RS, the first line PQ, the gradient is M1. The second line RS, the gradient is M2. And from what we have here, we said that M is equal to tan theta. So that means from here, our M1 will be equal to tan theta 1, and M2 will be equal to tan theta 2. So let the angle QTS, let it be angle theta. That means angle RTP will also be equal to theta. The reason I said is vertically opposite angle. Now, theta 1 is equal to theta plus theta 2. We want to get this theta, it is equal to this angle plus this angle. Two interior opposite angle is equal to one exterior angle. So, we can now get our theta from there to be equal to theta 1 minus theta 2. So if we introduce our tan to be here, tan theta is now equal to tan theta 1 minus tan theta 2. From your knowledge of double angle, sum of angles, angle formula, tan theta is equal to tan theta 1 minus tan theta 2 divided by 1 plus tan theta 1 tan theta 2. Then, what is our tan theta 1? We said it is M1. Then our tan theta 2 is m2. 1 plus m1 m2. So that is going to give us the angle between two. So our theta will be equal to arctan that. So which now gives us the angle between the two lines of gradient m1 and m2 is theta is equal to arctan m1 minus m2 divided by 1 plus m1 m2. Hence our theta is equal to m2 minus m1 and divided by 1 plus m1 m2. Now, it is important to note two things. Now, if the two lines are parallel, that means the angle between them is 0. That is, the line is like this, parallel lines. These lines are parallel. That means our theta will be what? 0 degree. But if they are parallel, then we have our m1 to be equal to m2. The gradient of the first line will be equal to the gradient of the second line. That is if they are parallel. But if the lines are perpendicular, this is for parallel lines. Now this is for perpendicular line. This is for perpendicular lines. That means the angle between them is 90. So if the angle between them is 90, then we can say that 0 is equal to 1 plus m1 m2. m1 m2 will be equal to minus 1. Then m1 is equal to minus 1 over m2. Or m2 is equal to minus 1 over m1. So that is gradient of the angle between two lines, then the gradient between them. If you are given a line, in the next class we shall be seeing examples of gradient of the line and gradients of lines between two lines. So if you are given a particular angle, a particular gradient, you can get the equation of the other line. If you are given two lines now, you know the gradient of the first line. Maybe they intersect at, if they are parallel, you know what to do. And if they are perpendicular, you know what to do. So once a gradient is given, you can determine the other term. So this is what we have for us today. Let's go through it, and in subsequent class we shall see how to solve problems involving gradients of lines and the likes. Thank you very much and have a nice day.